Hello, everyone. My name is Kristof Van de Reck, and I will talk to you about blockchain implementation with a focus on NEM. I'm the council member and regional head for Europe for NEM Foundation. Let's talk a little bit about blockchain. I'm going to assume that most of you know what blockchain is. So I'd like to focus a little bit on why to use blockchain. So inherently to blockchain, we have the cryptographic features. And as a result, we assume security. So that's obviously one of the main major reasons to use blockchain. But also traceability. We heard it before in previous talks. Having an auditable trail, and also having the ability to link this auditable trail to individuals and identities is a major thing that provides the benefits of blockchain. As a third item, I wouldn't necessarily call it trustless because people that are it may be misconceived, but obviously we would trust the technology rather than the actors. So if we trust the technology, if we did the identification, we can basically build systems that are nearly trustless. And then distributed. As a last thing, obviously, the distributed nature of the technology makes it redundant and also provides a very high cost reduction. We heard it in the previous talk, the amount of cost reduction it can establish just only in the financial sector. So you can imagine in all sectors together how big this cost reduction could be. I think also one of the things that are really important is that we consider where it's not a good idea to implement blockchain. One of the strengths of blockchain, actually all the things that I mentioned earlier, are also at the same time weaknesses. Immutability. I think this is one of the main disadvantages of blockchain. It makes it really difficult to have long-term goals for blockchain applications. Makes it really difficult to amend your blockchain applications with new features and things like that. The distributed nature of blockchain is also something that's quite of a little bit of a disadvantage. We have all heard about scalability issues with blockchains, especially public blockchains. So obviously, due to propagation speed, the bigger the network of nodes is, the longer it will take before all the transactions are propagated throughout the network. And also the inefficiency. Obviously, if we store the same data set on a couple thousand nodes, it's a very good from a redundancy practice, but at the same time, it makes things very inefficient. Same goes for computing. Last but not least, the transparency, which is one of the main characteristics of especially public blockchains, also raise some privacy concerns. Next up, smart contracts. We usually, when we talk about blockchain, we always have to talk about smart contracts, right? So, but one thing we have to realize is that smart contracts didn't came about with blockchain. Already in 1996, Nick Szabo defined the terminology of smart contracts. And then it became known in blockchain basically for the implementation of smart contracts on the Ethereum platform. So let me talk a little bit about blockchain implementation. I'll quickly take a small sip of water. Blockchain implementation. So we all, at least I suppose, we all realize the potential of blockchain. But what is the exact value proposition for the use cases we're thinking about? As a second thing, it's highly disruptive. So for existing businesses, this means that it's difficult for them to transition towards blockchain implementation because of the fact that they basically need to replace some of their core processes with blockchain technology. But also for startups that are working on new business models, shouldn't be underestimated how difficult it is to build decentralized applications or even things that are more centralized. Last, in all honesty, we have to, in my opinion, say that the technology is still pretty immature and complex. By this, I don't mean individual blockchains or individual platforms, but I think before we will see a real maturity of blockchains in general, we will need to have a better intercompatibility, interoperability, and some other second layers like we saw with the internet. Very briefly, this is like a common track for blockchain implementation. First, you start to explore the possibilities of blockchain. Basically, the result of that is usually that you form yourself an idea of what blockchain can do. Then, in a lot of cases, it's decided to do some experiment with blockchain. But in all honesty, there is not a lot of implementation going on, at least in enterprise things. This will, obviously, they're working on it, but this will take a little bit longer, I guess. So this first phase, one of the most common outcomes for this is actually that they end up with more questions than answers. What's the scope? Where to apply blockchain, where not to apply blockchain. In my opinion, there's a very thin line where blockchain actually makes sense and where it's overkill and where it's basically causing more scalability issues without having the actual benefit of using the blockchain. So in my opinion, that's really important to do proper assessment on that. Then one of the difficult things, again, due to the maturity of these technologies, is the assessment of which platform is the most suitable. Next up, difficulty in linking existing systems to the new technology. I said this before. And then last but not least, assessing the actual risk to reward ratio. And I think, obviously, administrative simplification can bring a lot of benefits to enterprises. But we also have to realize that a lot of enterprises have take a look at blockchain, and they say like, okay, we have working systems, why would we replace some of our core processes, do all this disruption while everything is working fine for us now? So basically we have two common results. Either they wait and see, or they say like, okay, let's do some experiment, a proof of concept or a pilot, and let's take the approach to fail fast and to learn from it. Although plans may be ambitious, taking these little baby steps is still one of the most common approaches, where they choose a narrow scope with, in a lot of cases, a small buy process somewhere at the edge of the operations, and a very simple use case. Also, usually I see that a lot of them are actually choosing for a very flexible technology with smart contracts as a risk mitigation against the immutability. In a lot of cases, the outcome of this is that they end up with a very complex microservice that provides little benefit. Remember, the blockchain challenges are transparency, adapting to the immutability, and also the scalability. But also, I have said before, one of the main reasons to use blockchain is security. And in all honesty, we have to admit that we have seen over the course of this year a couple situations where security wasn't really the outcome of the blockchain use. I think that especially when smart contracts become really complicated, it becomes actually practically nearly unmanageable for developers to ensure the security in the end result. NEM is a little bit different. So, what's the NEM approach? We were actually thinking how much of this application logic on the blockchain protocol level actually makes sense. How much do you need to leverage on the potential of blockchain? And actually, even without application logic on the blockchain, we can still use it for transfer and store of value. I think that's very obvious with cryptocurrencies and Bitcoin and whatever. Also authorization, traceability, and the authentication of identity and data. So in NEM, we don't have a smart contract system. We have a smart asset system. In this example, we see two assets, the green things, that are linked to namespaces, to a namespace. And also on the right-hand side, we can see the multi-signature feature. These are actually simple building blocks that with the proper, with the right use and with proper creatively using these building blocks, most applications that are actually viable use cases on blockchain can be built. So I'll give a little bit more, let's go a little bit deeper in the anatomy of a NEM application. Actually, there's three major components in NEM application. First of all, there's a governance model. Basically, it's about managing the authorization. Then, secondly, there's a data model, and obviously, the application logic. One of the most important things is actually the governance model, where you would manage the authorization. So obviously, before you can manage authorization, you need to identify people. We have seen this in previous talks. There has been quite some talks about identity already. Actually, closing the gap between the digital and the physical world is in most instances, the first thing we need to do. Once we did this, we can build authorization management with assets. Here I have a small slide with, on the right-hand side, we have a user account that has already been identified. So it's linked to that physical identity. And on the left-hand side, we have a multi-signature account with two co-signatories that are actually responsible for giving the actual authorization to the user account. So in order to do this, we use two assets, two tokens. The top one is an authorization token, and the bottom one is actually the revoke token. So obviously we cannot always assume that when we want to revoke an authorization that people will voluntarily give us the token back so that we can revoke the actual authorization. So that's why we could also send a revoke token, and we can use the blockchain as an authentic data source to query this specific account and see whether there's no revoke token. So that means that we can assure that this person has the authorization if the authorization token is in the account. One of the most, I think, challenging things to define a blockchain application is the data model. Before we store data on the blockchain, we need to consider a couple of factors. One of the most important one is obviously cost. Due to the inefficiency of blockchain, we need to consider, obviously, blockchain itself is more expensive than legacy databases. So we need to consider how we are going to do these transactions and what the cost is for doing this. Again, privacy. We need to make sure that when we store privacy-sensitive data, that we do this in such a way that there is no risk of exposing these privacy-sensitive data. Let's not forget, in Europe, there's the GDPR requirements that will come into effect in May next year. And they're actually there are very high fines for breaching the regulation on that account. And also we have to think about security with the storage of encrypted data. So where will we store data? We won't store all the data on the blockchain itself. We can also store some data off-chain in a distributed database like IPFS or something similar. or also in legacy database systems which are more centralized. The big question is, what makes sense? You can model these data in such a way that you still benefit from using blockchain, but obviously not all data should be completely decentralized. So this is a couple trajectories we can follow. Basically, on the top side, we have assets that again can be used to categorize certain data sets, and we can link them with messages, either normal, in plain text, or encrypted. And on the bottom side, we basically have usually the larger documents that would be stored on a decentralized, distributed database or a regular database. And then we would use fingerprinting to link between the blockchain itself and the data. Last but not least, I'd like to talk about the application logic. So once we have the governance model and the data model on the blockchain, we will already have part of the logic on the blockchain protocol level. This is inherently in the building blocks that are on the NEM blockchain. So there's a couple features that enable automation on the blockchain level. But now we can develop blockchain applications that use the blockchain as an authentic data source. The smart asset system allows us to develop applications where blockchain logic is used in combination with client and or server-side logic. My next slide shows a couple common scenarios. So we can use some of the application logic. We can put it in a mobile app or in the web applications, or even put some, like reuse some application logic from existing clients. Also, we have the ability to have some middle layers that will be used to amend or to change the existing logic and leverage on the potential of blockchain. So, the simplicity of this smart asset system is actually forcing us to question a lot of challenges early on in the stage. Whereas when you use smart contracts, you basically have all the possibilities to later on amend whatever your plan is and whatever. But by being bound to these simple building blocks, you really need to have the answers of all the difficult challenges in the early stages, which will basically shift the challenge from a later stage to the early stage exploration phase. In my opinion, that's one of the main reasons why we see a lot of people being very successful when using the smart asset system. It still allows us to leverage on the potential of blockchain. It makes developing blockchain applications more secure because of the simplicity. So you don't need developers don't need to think about all the possibilities because you're basically limiting the application logic on the blockchain is very limited. And it makes it easier and faster to develop on blockchain. Compared to other blockchains, we have two common tracks to implementation, where the top side is actually a smart contract blockchain, where initially you would do that the scope definition, and data modeling, contract development, debugging, which is obviously necessary, and contract audit, which is also necessary due to the complexity. And then you can start your application development. On NEM, you obviously also have to do the scope definition, and then, as I said, authorization modeling, data modeling, and application development. This actually results in a very big cost and time reduction when actually you are able to use the smart asset system. And actually, most of the applications can be built on such a on a smart asset system on the NEM blockchain platform. So this was my probably a little bit too short presentation, But
Thank you,
this gives us some time for questions.
Yes,
Yes, we have.
Yes, Kristof. All right. The first question is from me myself. Could you speak more about development of NEM blockchain? What's the current state? What's going to happen in the nearest future?
You mean the protocol itself?
Yeah, the protocol itself.
Yes, so our developers have been working since 2016 on a new iteration, again, built from scratch. The current version of NEM is also built from scratch. But the new version is again built from scratch in C++ rather than the Java version, which we are currently running. And it's nearing completion, at least for the private chain, it's already operational. We expect to release somewhere in 2018 for the public chain. And actually it will allow for some new features like aggregate transaction, which is basically like a multi-party settlement, like a multi-party atomic transaction, which I'm really excited about because it's one of the automation features we were still missing. So yeah, that's on the protocol level, but there's a lot of new features that are built in Catapult, but we are also working at the lower level to provide more support to developers. We have heard in the previous talk that finding good blockchain developers is one of the main challenges, so we are trying to make the entry barrier into blockchain as low as possible. So we'll build 4 different libraries in Java, JavaScript, C#, and Python, and build some more supporting structure for our developers.
That's great. That's great.
Thank you. And also I have a few questions from the audience. The first question from Bogdan. Existing blockchain technology doesn't know anything about real life. It is bring us to have some kind of oracle to improve any event in real world, especially when we talk about smart contract realization. What do you think about this? How this oracle will be implemented?
Yeah, well, that's actually a very good question, I think, because a lot of people are really really fell in love with smart contracts because like the unstoppable decentralized code, and obviously I also like the concept very much, but oracles is something that's really important in that mindset, because oracles are actually usually centralized inputs into a decentralized application. So my question would be, why do you really want to put all this application logic on the blockchain while you still have centralized oracles? In my opinion, it's not really a big issue to have centralized oracles, but the question is, if you already have some centralization, what's the real benefit of making a decentralized smart contract? So the way this could work in NEM is basically still use the oracles, but use them as inputs of your application logic as off-chain smart contracts, and use the outputs of these off-chain smart contracts to drive the transactions on the blockchain.
Thank you. And the last one?
Thank you. The last one, the next one. Could you speak more about out-of-the-box solutions and what NEM blockchain brings to the businesses or anybody who wanted to adopt and use NEM blockchain?
Yeah, sure. In all honesty, we're still working on providing a little bit more structure to the applications, open source application we already have. But we have a couple that are actually working out of the box. One of them is a voting module that is in a Nano wallet, which is the default desktop wallet for NEM. But also we have an apostille feature, which is also a module in the Nano wallet, which basically does similar things to Factom, where you can notarize documents and also make them transferable. There's also an open source project called Landstead, which is for land registry, which was actually built, and this is really impressive, it was built in a couple of days for as a proof of concept. But we also have like a lot of smaller open source applications. So there's actually quite a lot. I wouldn't say that all of them are really production ready, but they really show the simplicity of building them. So.
Great. And one more question from the audience. What is the world practice about implementation of blockchain in the real estate business? And especially for land purchase, or attracting investments, or building houses and commercial real estate?
Well, that's a difficult question, I guess.
It is.
So, I think that's one of the things, in my opinion, that is an attestament of the maturity of blockchain, because at this time, I don't think there's like one set way to do specific things. I think we are still evolving into more standardization. I think one of the first standards was actually like the ERC20 token, but that's into one like the Ethereum, what should I say, the Ethereum ecosystem. And I think one of the things we will see in the future is basically more of a standardization across different blockchain protocols, but this will probably take a couple more years.
Does NEM bring some solutions for real estate?
Well, as I said, there's the Lansted proof of was built, which is open source, and this is it's not a fully operational, like it's not end-to-end providing all the features that are required for a production application, but it shows basically how the most important things can be done, like registering users and then assigning properties to them, and also transferring properties. And so this might be interesting to have a look at it, if that's something that interests you.
Thank you very much, Kristof.
Thank you.
Поблагодарим Кристофа за отличное выступление.